Hello, 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 ladies and gentlemen, and welcome back. Root Beer here with more of the 2001 Cayley paper. We're up to question number 14, so we're sort of right in the middle of part B. All our questions are worth 6 marks. And question number 14 says, in the rectangle shown, the value of a minus b is... So we have a rectangle here, we've got some coordinates, 5, 5, 9, 2, we have a, 13, and 15b. Now, I did this question on the 2001 Cayley because there is a lot of overlap. They tend to overlap questions. In fact, I believe there's a water jug question involving a cylinder on top of another cylinder that's on the Pascal Cayley format. And I did it a particular way on the Pascal. I did it sort of just by analyzing rise over run. So you can actually go back and find it. I have no idea which question number it actually was. But, of course, you can click the link in the description. It's going to take you to the Waterloo website. You can click on the Pascal for this year, and you'll figure out what number it was. I want to say it was 17, 16, 17, maybe even 18. One of those ones. So if you want another way to do this question, you can go back and take a look at that. Same question, just on the Pascal, and it's going to be a larger number than 14 because the hard questions on the Pascal become the medium questions on the Cayley, become the easy questions on the format. So we're going to go through this in a different way. What we're going to do is we're actually going to figure out the lines that A, 13, and 15b are on, and show how to calculate A and B directly. And then once we have A and B, the coordinates, we'll do A minus B and get our answer. Okay? So that's what we're going to do. But if you want a different way to do it, by all means, take a look at my Pascal paper video. I think it was 17. I want to say it was 17. Okay. Maybe somebody could post in the comments which one it actually is. So, let's draw our picture. Get ourselves a brand new piece of paper and get a picture going. So we have A13 and 15B, and then we have 9, 2 down here, and 5, 5. Okay, just going to double check, make sure I got those coordinates right. Yeah, 15 and then B. All right. And we'll make this 5 look like a 5. I know sometimes my 5s, when I do them really quickly, look like 3s. Okay. So the way I did it in the Pascal video, which I'm not actually going to go through right here, is I just said this rise over run has got to be the same as this rise over run. So you can translate it really quickly. What we're going to do is we're going to figure out the equation of this line, this green line here. And once we have the slope of that line, we'll have the slope of the other two lines, the ones that have A and B on them. And the reason being, because it's a rectangle, we have right angles here. And so we'll get the slope of this blue line, and it'll be the same as the slope of this red line, because being rectangles, they are parallel. Once we have the slope, we have some points on them, so we can use what's called point-slope form of the line. So for any, if we're given any pair of coordinates, we can determine a line through them using rise over run. We take the difference in the y coordinates, so 2 minus 5, over the difference in the corresponding x coordinates, so 9 minus 5, and we get minus 3 over 4, so minus 1/3. So the blue and red lines are perpendicular. Perpendicular to the green line. So their slopes are going to be negative reciprocals. Okay, so if I have a line here and it's got a slope of m, any perpendicular line will have a slope of -1 over m. Okay, this is kind of a useful fact that you usually learn in 9th grade or maybe even 10th grade. Okay. So the blue and red lines, they're going to have the same slope because they're parallel. -1 over the slope of the green line, so -3/4. And that works out to be 4 over 3. So now we can use what's called point-slope form of the line. So if I have a slope m and I have a point x0, y0 on the line, then I can get an equation of a line y minus y0 is equal to m x minus x0. This is called the point-slope form of the line because you need a point and a slope for it. So we know the blue line has a slope of 4/3, and it's got a point on it. So y minus 5 equals 4/3 x minus 5. And the red line, well, it's got the same slope, but a different point. So x minus 9, y minus 2. So these are point-slope forms of the line. Now, we know that A13 is also on the blue line. So that means 13 minus 5 is 4/3 A minus 5. So 8 is 4/3 A minus 5. And multiply by 3 on both sides, we get 24 is 4A minus 5. So 6 is A minus 5. And A is going to be 11. Okay? And we know that 15B is on the red line. So that means B, which is the y coordinate, minus 2 is 4/3 15 minus 9. So that's 4/3 6, which is 8. So B is 8 plus 2, which is equal to 10. Now the question asked us for A minus B. So that's 11 minus 10, which is equal to 1. And that's the final answer we want. And that's the same answer I think we got on the Pascal. Again, you can go back and check that video. So we're going to go with an answer of E. Okay. So that does it for question number 14 on the Cayley. I don't remember if this shows up on the format. I don't think it does. But sometimes you can find questions on 2 of the 3 contests, or even all 3 of them. So in the next video, we're going to take a look at question number 15. Thank you guys so much for watching, and I'll see you in the next video.